Hi everyone, welcome back. In our previous videos, we talked about the world of K-neighbors algorithm, from understanding its foundational principles to going into the deep concepts of determining the optimal value of K. In this video, we will get into a crucial aspect that often arises in KNN model, essentially breaking the tie. So in case of KNN, the scenarios may arise where two or more neighbors share the same distances from the target data point, and that creates a tie situation, and that needs to be handled. Breaking this tie becomes essential for refining the precision and reliability of our prediction model, which is using KNN. Whether it is based on the voting mechanism or proximity or some other techniques, understanding how this is actually done by scikit-learn behind the scene, or if you're writing your own custom package, how you can implement it on your own. That's the skill that will really help you build the machine learning models in a proper way. So let's get started. The tie break is a situation where the k-neighbors algorithm where we have a tie. The ties may occur when there are multiple neighbors for the same with the same distance for the target data point. Breaking tie involves deciding how to handle situations, which is creating the ambiguity in predictions. So there are multiple techniques involved here, or multiple techniques possible here, how to break the tie. But then first is we need to find out how whether the tie breaks actually exist. So how do we find out if the tie breaks exist? So essentially after finding the k nearest neighbors for a particular data point, we just find out the distribution of the class label for the data point. If there are equal count of two or more classes for the data point, that means there is a tie break. How we can handle the tie break using odd number of neighbors? That's the simplest of these strategies that we can use. And this works pretty much in case of binary classification where we have two classes. But if there are three classes, then this approach may not work. So we have mechanisms like weighted voting. That means in this case, we are going to look at the distances of the neighbors from the test data point. And the way we look at it is in terms of inverse of the distance. That means inverse of the distance means for the further the distance, you just reciprocate it. That means you get a higher weightage or a higher influence for the samples which are actually closer in terms of distance. So scikit-learn supports this mechanism using the weights parameter. You can also do random selection. When you have tie situation, you randomly or arbitrarily pick one of these. Scikit-learn does not provide explicit support for random selection. So the weights parameter in scikit-learn has two different settings that you can use. One is the weights is equal to uniform. In this case, all the neighbors are given equal treatment or equal weight in decision making or final voting for prediction. So regardless of the distance of the test point from the training samples, each neighbor is treated equally. You can also set it to weights is equal to distance. In this case, the weights come into the picture and each neighbor's weight is inversely proportional to the distance. And the neighbors with the higher influence, while the further neighbors have less impact, the closer neighbors will impact more in terms of the weight and influence. Let's take some example here. Let's say we have these data points, data 1 to data 10. And test class is unknown for a test data point. Nearest neighbors are like this. The distribution is between class 0, class 1 and 2. So there are two samples or two cases of class 0, two cases of case of class 2 and two cases of class 1. So class 0 has two votes, class 1 also has two votes, and class 2 has one vote. So there is a tie situation here. So when we have weights is equal to uniform, then in this case, how scikit-learn will handle this? So by choosing the class label that appears first in the sorted list of the label names, that's how it's going to decide or break the tie. For example, if you have a neighbor 1, 2, 3, 4, 5, and the labels are A, B, and C. Two instances of A, two instances of B, and one instance of C. In this case, the label A, so there is a tie between A and B, and the A appears first in the list of labels. So the prediction is going to be A in this case. When we have weights is equal to distance, then in that case, let's say the neighbors A 1, 2, 3, 4, 5, and they're distributed across the classes, and their distances from the test point, for example, 0 0.5, 0 0.8, and so on and so forth. So what we do here, the class A and B are in tie. So the tie between A and B, both having two votes. So scikit-learn will give more weight to the class with the closer neighbors, because the closer neighbors, reciprocal of that, would give a higher weightage. So class A, just do a reciprocal of for class A 1 over 0.5, and second one also 1 over 0.5. That's the weight of 4. And likewise B will be 1 over 0.8 and 1 over 0.8 again, so 2.5. So in this particular case, class A wins. Now, which setting to use when? That would depend on the output that you get. So let's take a look at the Python code and see how it is configured. Let's take a look at the simple code, and I'm going to use the iris data and key neighbors classifier. Load the data here, iris data, and train a particular model, KNN. It could be anything here, but KNN, for example, and tie break is empty. Now we're going to leave one out cross validation method to detect if there are any tie breaks or not. So prepare the training data. So and then after that we have a test data. So test data become the query point. So let's train the model, and then we get the neighbors for the test samples. And after that, the neighbors return the labels. So get the labels for all the get the labels for all the neighbors of the test points. And then after that, we can do a counting. So if you do a count here, in this particular case, we did not find any tie break situation. If there are tie break situation, then we should examine and see which particular rows are involved in the tie break. Likewise, you can also do here. So let's try out for the range of 30. That means, the k is equal to 1 to 31. And in this case, also, you will find here that for each value of neighbors, just see there are no tie break situation. So these are like, the methods that we should use to explore and find out if there are any tie break situations or not. Next step would be to set the values to values in the model setting, weights parameter to uniform and distance, that we will see in our tuning section. I hope this explanation was useful. So that was a quick demo on how we handle tie breaks or how scikit-learn can handle tie breaks situations in KNN. In the next topic, we'll talk about how the importance of scaling in neighbors algorithm. Thanks for watching. See you in the next video.